Activity 10.10 is triangle similarity. And in congruent triangles, we learned that all the sides and all the angles have to be exactly the same. We will learn in triangle similarity that your angles will need to be the same, but your sides will be proportional. And that's what you see with these two triangles that are drawn here. So your sides are proportional. I'm supposed to put in the slashes through them. We'll put little squiggly lines. So these are proportional. These are. That means they have the same ratio. But the sides are going to be, that looks like a right triangle, so I'll make that symbol exactly the same. So the angles are, the angles are exactly the same. Those are congruent, and the sides are proportional. And when you look, you can also do reciprocal of sides. You can do ratios within a triangle. We'll look at different ones. There are only three properties for similar triangles. The first one, just like congruence, is side, side, side. And we have an example. Devin wishes to build a scale model of one of the pyramids in Egypt. Assuming each side of the pyramid is an isosceles triangle, you suppose the three sides of one of the triangles, the base. So I'm going to try to draw a picture of this. The base is 1,000 feet, and the two sides are 1,300 feet. Then we're going to have a scale model with a base of 8 inches, and you want to know the side. So suppose we know the sides are proportional, then we can set up the following ratios. So this is where I said you can look above, you can do it from triangle to triangle, or you can do it within a triangle. But we can do, for example, the 1,300 over question mark would be proportional to 1,000 over 8. Since we have the same measurements within a triangle, you don't have to worry about the units in this one. If you have different units of measurement within a triangle, we have to worry about it. We don't for this one. So if we're solving, it has to have the same ratio. You can cross multiply if you want to. 1,300 times 8 equals 1,000 times question mark. And then divide both sides by 1,000. And I'm going to find a calculator. And I will do 1,300 times 8 divided by 1,000 is 10.4. And that was 8 inches. That would be in inches. Okay, like I said, 3 properties. So let's go ahead and look at the second one. Angle, angle. We don't say angle, 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 because the third angle we know has to be the same because they have to add up to 180. This was not a congruence property, but it is a similarity property. Shadows are pretty popular examples for this. So let's read our example. At a certain time of day, a flag will cast a shadow of 40 feet right here. So if you can picture, somewhere up here would be my sun, and sun shining, you cast the shadow. This would be your flagpole right here. So here's your flagpole. At the same time, a student who's 5 feet 6 inches tall casts a shadow of 8 feet. How tall is the flagpole? So we have the same angles because you're assuming the flagpole and the student make a 90-degree angle with the ground. We also assume that the angle of the sun is the same, and that's the two angles. This is where I said if you have different measurements within a triangle, you have to adjust. So we need to think about how many inches are in a foot, and there are 12 inches in 1 foot. So 6 inches is a half of a foot. So this becomes 5.5 feet. Now I can write up a proportion, and I can do, for example, 8 over 40 would be 5.5 over the height A. Oops, I wrote that in the wrong spot, but I did say this um, out loud. It's angle because there's a 90-degree angle with the ground, and the angle of the sun is congruent. We'll use the rest of the space to cross multiply. 8 times A equals 40 times 5.5. We're going to divide by 8. Again, take out your calculator, and I will do 40 times 5.5, and then I will divide by 80, and I get 27.5. The third property is side angle side. Again, the order that we write those letters in matters, so it's an angle included between two sides. And the example here is not a word problem, but it's a picture. And we have that M divides both segments A to C and B to D, such that A to M is half of MC. Well, A to M is 8. That means M to C would be 16 because 8 is half of 16. And BM is half of MD. Well, 18 is half of 36. We know A to B is 24. Well, 24 is half of 48. We can set up a proportion, but I don't think we need to if the ratio of the sides is going to be, well, in a smaller triangle, it's half. If you'll get the bigger one, it would be double. So I can just say that that is going to be 48, and that is inches again. And those are the three properties for similar triangles.